Yes, I welcome all participants taking this course. I'll be taking you course 201, and the title of this course is Introduction to Computer Programming. Now, introduction, human beings communicate using natural languages, but what the computer understand is machine language, which is a binary digit, and that's zeros and one. So therefore, programming language was developed to allow humans to communicate with the computers. Now, first, what is programming language? It is a system of rules. Note it, system of rules, syntax and symbols used to write instructions that computer understands, and it serves as a communication bridge. And what are the objectives? One, natural language and the computers. Here you will understand why natural languages can't communicate directly with the computers. Reason being that the computer only understands zeros and one, like I said in the previous slides. And when you talk about natural languages, you're talking about your English, your French, your Igbo, your Hausa, and so on and so forth. Then the objective two, you'll be learning the programming languages category. Here you identify different categories and types of programming languages. Now, note this, there's difference between categories of programming and types of programming. So as we go on, you will also learn that. And here we'll also learn about language translators. Now, for instance, let's assume you write English-like codes using any of the high-level languages. Then what happens, what the translator does, it converts it into what the computer understands in terms of interpreting or doing what you have asked it to do. Then the number 4, programming principles and stages. Here you learn the guiding principles and stages involved in programming. Then number 5, programming errors and debugging. Here you'll try to understand, after writing your code, how to debug errors, understanding errors, and how to make your code run even though it has run into error. Then natural language versus programming language. One, you have the natural languages. These are examples, just like I said in the previous slide: English, French, Yoruba, etc. Then you have the machine language. These are only language the computer understands, which consists of binary codes. That's your zeros and your ones. Then you also have the programming languages. This serves as a bridge between humans and the computer. For instance, you have to tell the machine what to do. This is the human, this is your machine, and this is your computer. So then we'll talk about the limitations of natural languages. And what are the limitations? We have 1, complexity. Many rules and exceptions make natural language hard for computers to understand. Simply means the computer does not really understand a boy must carry a cup. There must be a precise instruction for it. Now, irregularities, for instance, now I am an Igbo man and I stay in the Yoruba land. You don't expect me to just speak Yoruba fluently. Are you getting my point? But when it comes to my own dialect, I can speak it fluently. So I have to learn Yoruba over time. But in the process of learning, there is something we call irregularities. That is the problem of the system. It does not understand that over time. Then limited abstraction. Pronouns can cause ambiguity. And what is ambiguity? Different types of words coming together. The computer is yet to also understand that. On economic expression, the computer requires precise instruction. When dealing with your system, precise instruction is very, very important in terms of carrying out tasks. We talk about ambiguity, which often have multiple meanings. For instance, to you now, this is a boy, might mean you're actually saying this is a boy, but to the computer, this is a boy can actually mean something else. Then categories of programming, we have the procedural language. This focuses on step-by-step instruction. For instance, we have the Fortran, the BASIC, and the likes. So, and also as we go on, you also understand what we call pseudocode, which is also a step-by-step instruction. Then we also have structured language. This improves readability and modularity. Very, very important, because you don't just sit down to write language. It should be readable, and it should be able to modify it. Then examples of that are your C and your Pascal and your Ada as well. Then the number 3, we have object-oriented programming. This organizes your data methods into objects, and examples are your Java, your C++, your Python. Then types of programming language. Now, this is where the trick is. Like I said in our previous slide, that here you understand the types of programming and the categories. Note, categories and types are not the same thing. So I will do a clarification here. So the types of programming, you have machine language. These are codes written in zeros and ones, or English-like codes that are transformed into machine language, that's zeros and one. Then you have your assembly language, which uses mnemonics, which is easier for humans to read. For instance, you have your aux, load 2 into 1, and so on and so forth. Then you have your high-level language, which resembles the human language. Like, for instance, we talked about the C, the C++. Those are English-like programming language, which are user-friendly. And you have your C, your Java, and so on and so forth. Then language translators. For instance, if you recall that I said assembly languages uses mnemonics. For instance now, languages that are written in assembly language, the translator used for decoding or for interpreting that language is an assembler for the machine to understand. This converts assembly codes into machine language. Then you have your compiler that translates complete program before execution. Then you also have your interpreter, which executes codes line by line. But note this, there's difference between these two. For instance, this is more faster than this. Why do I say it is more faster than this? It is because this compiles all your lines of code and debug them once, while your interpreter interprets them line by line and debugs the error line by line. So it is slower when it comes to execution. Now, principles of good programming should be efficient, optimal for use of resource. Reliability should be consistent and correct result. Then robustness handles invalid input, should be able to handle invalid input. Then user friendliness, very, very important. Every of your program written, every of your code, every of your algorithm should be user friendly. Then maintainability, easy for updates. You don't just write program that is not updatable. You should be able to update and do modifications on your program. Stages of programming, we have problem definition. Ability to, we'll also talk that in our next study, but ability to define your problem, very, very important. Sit down to do your solution design using algorithms or flowcharts. Then, and what are flowcharts? Those are designs used to explain your algorithms or your codes. Now, coding, writing the program, then testing and debugging. This is running your program several times just to debug error, ensuring that before deployment, your program is error-free. Then you have documentation and maintenance. Very, very important. Keep records and updates. For instance, don't just write a code. Document things. Know where and where you have done. Know every phases you have touched, every stages you have touched. Then we also have debugging and programming. Now, error types. You have the human error, you have the syntax error, logic error, runtime errors. Then debugging levels, we have the dex checking. That's going over and over your code and using error messages. That's going over and over your codes to check for errors. And using error messages. Now, in summary, programming languages facilitates human-computers interaction, covering language categories, translators, principles, stages, and debugging. So see you in our next study. Thank you very much.